Good morning to all. Today we are going to discuss about the Milne-Thomson method. Using Milne-Thomson method, we can construct the analytic function. That means one of the value is given. That means if the real part is given, we can find the imaginary part and the analytic function. Or if the imaginary part is given, we can find the analytic function as well as real part also. Generally, we denote our function as let f of z be an analytic function. We denote f of z as u plus iv. Suppose here u is the real part, v is the imaginary part. If u is given, then take the f dash z value as u suffix x. U suffix x means what? Dou u by dou x minus I into u suffix y. That means dou u by dou y. Suppose V is given. If V is given, then take f dash z equal to V suffix y. That means dou V by dou y plus I into dou V by dou x. If U is given, take this f dash z value, or V is given, take this f dash z value. After that, replace x by z and y by 0 in f dash z. Substituting x equal to z and y equal to 0 in f dash z. Then that what is the meaning of that one? X is converted to the z values, y values are 0. That means the entire value is converted to single variable. After that, you have to integrate f dash z value with respect to z. We get the f of z value. This is our analytic function. Let us look at the problem. Find the analytic function whose real part is x cube minus 3xy square. So here real part is given. We need to find the analytic function f of z value. Let us take u equal to x cube minus 3xy square. Differentiating u value with respect to x. So u is given. So we can differentiate u value with respect to x and y only using the given data. With respect to x case, y constant, x cube differentiation 3x square, 3y square constant, x differentiation 1, so 3y square. Next, with respect to y, dou u by dou y equal to x a constant, so x cube term is 0, there is no y value, minus 3x into y square differentiation 2y into 3x, 6xy. Now take the f dash z value. If u is given, we are taking ux minus iuy. So dou u by dou x minus I into dou u by dou y. Dou u by dou x value 3x square minus 3y square minus I into minus 6xy. Multiplying by minus I into 6xy. Next step is replace x by z and y by 0. Substituting x equal to z and y equal to 0. Then f dash z equal to y term 0. So second term 0. Here also y term 0. Y into 0 into any value is 0. This term is also 0. We have only first term. We are substituting x equal to z. So 3z square. Now integrating integral f dash z dz equal to integral 3z square dz plus integral constant. So integration and differentiation, we are applying the same function. So integration and differentiation cancel, we get function only f of z. 3 into z square integration z cube by 3 cancel plus integral constant. So f of z equal to z cube plus c. This is our analytic function. Here u is given. We have calculated the f of z value. Next, find the conjugate harmonic function of the harmonic function u equal to x square minus y square. So in this case, we have to find the conjugate harmonic function. So real part is given, find the imaginary part or analytic function. Our imaginary part is given, find the real part and analytic function. Similar manner, harmonic function is given, find conjugate harmonic function. We are using the same method, Milne-Thomson method. First, we need to check whether this u is harmonic or not. Harmonic means what? It satisfies the Laplace equation. So take u value x square minus y square. Laplace equation means what? We need to differentiate u value with respect to x 2 times, with respect to y 2 times. First differentiating this u value with respect to x and y separately. First differentiating with respect to x, dou u by dou x equal to, with respect to x, y constant 0, x square differentiation 2x. With respect to y, dou u by dou y equal to x square 0 minus y square differentiation minus 2y. Next, again differentiating these two values with respect to x and y, we get the second order derivatives. So one time x, again we are applying x. So second order derivative is denoted by dou square u by dou x square. 2x differentiation 2. One time y, we are applying again y. Second order derivative is dou square u by dou y square. That is minus 2. So if you add these two derivatives, their sum is equal to 0. We can say Laplace equation is satisfied. So dou square u by dou x square plus dou square u by dou y square. 2 and minus 2 equal to 0. That means Laplace equation is satisfied. So u is said to be harmonic function. So we need to find the conjugate harmonic. So u is harmonic means what? V is a conjugate harmonic. So we want to find the V value if u is given. Take the average z value, dou u by dou x plus I into dou v by dou x. Dou v by dou x. From the CR equations, we can write what? Dou v by dou x equal to minus dou u by dou y. So dou u by dou x minus I into dou u by dou y. Dou u by dou x value 2x and dou u by dou y value minus 2y. Minus into minus plus 2iy. So f dash z is 2x plus 2iy. Now next step, replace x by z and y by 0. Substituting x equal to z and y equal to 0. Second term is 0. Only first term exists, that is 2z. F dash z is 2z. Integrating integral of f dash z dz equal to integral of 2z dz plus integral constant. So integration and differentiation cancel. We have only f of z. 2 into z integration z square by 2 plus c. So z square plus c, 2 to cancel. So in this case, we want to find the v value, harmonic conjugate. So substituting z value x plus iy whole square plus c, separating the real and imaginary parts. This is a plus b whole square form, a square x square b square iy whole square, that means minus y square plus 2ixy, 2ab term plus c. So generally we denote f of z as u plus iv. Separating the real and imaginary parts, x square minus y square plus I into 2xy plus c. So in this case, in our problem, u is given. What is u? X square minus y square. That means this part is exist here. So remaining part is our imaginary part v, that is called the complex conjugate, that is 2xy plus c. So complex conjugate is v equal to 2xy plus c. So one of the part is given, we can find the other part and corresponding analytic function also. Our harmonic function is given, we can find the conjugate harmonic function.